Okay, today this is the day 5 review for formative on evaluating inverse trig functions and graphing inverse trig functions. So the first problem on the warm-up, actually I'd like you to do all 5 problems of the warm-up right now. Go ahead and pause this, and when you're done, come on back. Okay, your first question here is asking for the arc sine of pi over 6. So from your unit circle, the sine of pi over 6 is 1/2. So therefore, we're looking for arc sine, which again, as you know, is arc sine or sine inverse of 1/2. So it wants to know, when is sine going to be 1/2? Why is this not focusing? Sorry about that. Let's try that again. Okay, when is sine going to be 1/2? So arc sine, if you remember from this chart here, is positive in quadrant number 1. And arc sine is 1/2 at pi over 6. So the answer is pi over 6. Now notice that this is the same as this. It is not always going to be the same, so you don't want to assume it's going to be and just write pi over 6 for your answer, because sometimes it is, sometimes it's not. There's different circumstances which we're just not going to worry about. Arc sine of 1/2. So arc sine is positive, again, in quadrant number 1. Cosine, sine, second number sine. So arc sine of 1/2 is pi over 6. So this was not a composite problem, it just had one piece to it. Okay. Third one. Cosine of arc sine of root 3 over 2. So we need to know when sine is going to be root 3 over 2. And sine is root 3 over 2 at pi over 3. So it wants to know what the cosine of pi over 3 is. Cosine pi over 3. So cosine is the first number in the ordered pair. And is this not focusing? Sorry. Put my pen, there we go. So cosine is pi over 3. So cosine of pi over 3 is 1/2. Okay, next one. Tangent of arc cosine of 1. So we're going to do this first. We're going to find arc cosine of 1. So you're going to take your arc cosine, and remember, arc cosine is quadrants number 1 and 2, and arc cosine is 1 at 0 or 0 pi. And now it's asking, what is the tangent at 0 pi? If you remember, at 0 pi, we're over here at 1, 0, and tangent is sine over cosine, or y over x. So that's going to be 0 over 1, which is 0. So the tangent of the arc cosine of 1 is actually equal to 0. Now we're looking at a problem where negative 3/4 is not is not a ratio from the unit circle. So we're going to take this information. Arc sine is negative in quadrant number 2. Remember, arc sine is positive in quadrant number 1, negative in quadrant number 2. So we're going to, sorry, that's not right. It's quadrant number 4. So positive in quadrant 1, negative in quadrant 4 for arc sine. So we're going to draw a triangle. We're going to draw it in quadrant number 4. Put our reference angle here. And this is arc sine. Arc sine is y, or sine is y over r. So our y value is negative 3. And our r value is 4. So we're going to use our Pythagorean theorem, x squared, or adapted, plus y squared equals r squared. And this is going to be x squared plus negative 3 squared equals 4 squared. So x squared is going to be equal to 7, and x is the square root of 7. So right up here, this fills in as, sorry about the dogs. No dog can walk by my house without that dog screaming. All right, so this takes care of creating our triangle here. Now what we want is the tangent of that. tangent is y over x. Tangent is y over x, so it's -3 over the square root of 7. And that can be left as is, or you are allowed to simplify it more if you want to rationalize it. But as far as we're concerned for this class, that's a great answer, and you should leave it as is. All right, we're going to go to the next page here in our notes. And we are going to do a quick review of graphs. So on your formative, you will have to do graphing of the 3 inverse functions. Notice that what I'm looking at here is a plot pointed at -1, negative pi over 2, 0, 0, and 1 pi over 2. I need to see those 3 points plotted. And then this is change in concavity here. Concave down, concave up. The domain is -1 less than or equal to x less than or equal to 1, or in interval notation it's written like this. The range is negative pi over 2 less than or equal to y less than or equal to pi over 2. Remember, it exists in quadrants 1 and quadrant 4, quadrant 1 and 4, between pi over 2 and negative pi over 2. Cosine inverse, you should have a point plotted at -1 pi, and a point at 1, 0 pi. You also, this passes through 0 pi over 2. And again, this is going to change your concavity here. Concave up, then concave down. Domain is -1 less than or equal to x less than or equal to 1. Or in interval notation, it looks like this. And the range is 0 less than or equal to y less than or equal to pi. This exists in quadrants 1 and 2 of the unit circle here. And finally, we have tan inverse. For this one, it's passing through 0, 0, and it's approaching pi over 2 and negative pi over 2 where there are asymptotes. So if you wanted a point plotted in between 1 pi over 4, -1, negative pi over 4, notice that, again, this is going to be a change in concavity here going through 0, 0. And they're approaching the asymptotes. Our domain is all real numbers, but our range are all the y values between negative pi over 2 and pi over 2, but not including those, because at pi over 2, negative pi over 2, we have asymptotes. So tan inverse exists in quadrants 1 and 4. Again, that's why we have this drawn between 1 and 4 for tan inverse, 1 and 4 for sine inverse, and cosine inverse quadrants 1 and 2. So what I'd like you to do right now is your page 25 classwork sheet. So that's the Finding Inverse Trig Functions 2 worksheet. So that is what you're going to work on now. So go ahead and pause the video and do these 4 problems. And when you're ready, go ahead and turn it back on. Okay, so to go through these problems, these are some combo problems. So we're going to deal with these a step at a time. The first 2 problems, the first problem we can get from the unit circle, and the other 3 are not from the unit circle. So we will have to draw triangles for each of those. And I knew that because tan inverse doesn't have a ratio of 1/2. Sine inverse -1/3 or cosine inverse -1/3 in the unit circle. Now this is asking for the sine of 5 pi over 4. So our pi over 4 in quadrant number 1, the sine value is, if this is pi over 4 in quadrant number 1, the ordered pair is √2 over 2, √2 over 2. So if we take that and stick that in quadrant number 3, where 5 pi over 4 is,